Wonderful. Okay, then I would, Adrian. Oh yeah, Adrian. The question is, I think it would be perfect to use this question probably to start the panel discussion. So I would maybe ask you to stop screen sharing, and then I would like to also ask all of the speakers from the session to join again, and then we can hopefully use Adrian's question directly to get the panel discussion started. So if David is also, yeah, David. Yeah, perfect. So Adrian, please go ahead.
Yeah, this is really for the last panel, or for the last presentation. Thanks for the very interesting presentation. I'm wondering, could you possibly consider just using another rendering engine and simply replacing the glyphs, basically making your own music font using some of those handwritten glyphs? Because it seems like you're kind of veering toward reinventing an entire engraving system, and that work clearly exists in other places.
Yes, that's one thing that we tried doing at the beginning. The problem with music fonts is when you use an engraving system, all the node heads look the same because there's just a single node head in the music font. So the problem is having different symbols for each occurrence of that symbol in the score. That's one problem that's hard to convince current engraving systems to do that. And the second problem is the variability in the layout. We need to randomize positions a lot, which is something these systems are not really designed to do. So all of these minor problems just mount, and at the end you say like, screw this, I'm gonna write it from scratch because I'm basically doing it anyways. And to the other point, yes, I'm basically reinventing the wheel here, kind of, and that's what I don't really want to do because the code bases of these engraving tools are like large monsters. I don't want to create another one. So that's why I'm considering other options, like, for example, learning the layout somehow and making the synthesis process less hard-coded. Well, let's see how it's going to turn out. Because I feel like if the learned layout rules are not perfect, that's not a problem for handwritten music because it just increases the variability slightly. And we don't need the score to look perfect like we do with engraving systems. So that's it.
Thank you. You are forgiven for reinventing. That makes perfect sense.
Paul, please go ahead.
Okay, so you mentioned that you tried the self-supervision route. So my question was, and kind of in a way to tie in also the work of David Rizzo and colleagues, because the thing about the Mustima characters and everything is that they might not represent the whole subset of possible handwritten styles and everything. So I was wondering, what exactly drew you away from using self-supervision? What did you try? And whether there exists other approaches so that we can basically exploit the multiple domains of music, such as the typeset scans that we were shown on the first data set, or other similar scenarios where we also have very limited data.
Well, with this semi-supervised learning, I realized, well, I did some very very focused experiments with symbol segmentation, and I tried to use synthetic data from my synthesizer to somehow learn the synthesis. Well, I didn't expect to talk about my diploma thesis, so I don't have the details at hand now. But the impression I've gotten from it is that semi-supervised learning didn't really help us, or at least the margin it would give us was so slim that it's like getting from 97% to 98%. That's good, but if we are like at 50%, it's too much work for too little gain. That's the feeling I got, but that might be just because the experiments I did were not like good. there might be situations where the semi-supervised approach is perfectly plausible and yields much better results. But the second part of the question, could you remind me what it was? Because it was something about MuStima++ dataset. Yeah, the fact that MuStima++ is quite limited in its style is true. And we would like to, well, most of this comes from the symbol synthesis stage. So if we train like generative models for symbol synthesis, or we use more symbol images, we hope that this could like help us generalize to other unseen music. That's our theory.
So basically you plan on synthesizing the components and then combining them with a typesetter.
Yeah.
Okay. That is interesting. Also, since you mentioned your diploma, is it public is it published anywhere?
Yes, it is. It's if you look up the MuStima, it's on my GitHub, and my diploma is there as well. So I think it's linked from there.
Okay, thank you very much.
I have one question that maybe goes to Jiří and David. So when we think about synthesizing versus manually annotating, maybe you can shed some lights on the efforts that you spent, because it sounds like synthesizing data set, you get something for free, but you don't. You also have to develop the system. So I would like maybe to understand, when you compare the approaches of like manually annotating this book that you've created versus creating a generator, what were the efforts that you had to spend on this? How expensive was it in terms of time, etc.?
Well, I would continue. The reason I started developing a synthesizer in the first place was that I wanted to train an end-to-end model. And end-to-end model requires an insane amount of data, because otherwise it overfits or it doesn't learn anything. So actually the direction from which I approached it was like, let's do data augmentation at such a low level that we can like permute the melodies for entire stuffs so that the model doesn't overfit. But let's keep the symbols that we have, because I think those are varied enough. So that's not really an answer to the question, but that's something I wanted to say.
I think that well, in the past we synthesized data for some many projects, and in what we have presented today is that we have everything is handcrafted. No, for example, what we have seen that there are many cases in which was your question, about the augmentation dot, that they should be there, and these kind of things cannot be automatic, cannot be done automatically. No, so I think that for testing purposes, we should use either manually tagging, or at least someone that corrects the synthesized data manually. This is there should be someone that checks that the encoding is correct. I think this is the point. Obviously, with manually tagged data, you cannot create any corpus worth to be used for machine learning, I think.
Yeah, I would agree. I think that those two approaches fill different needs. Like manual annotation is really good for evaluation, and synthetic data is really good for training.
One thing that we have a previous experience on that is that I remember when we did the Primus data set, that we were generating synthetic data, and the system, the network was able to identify mistakes in the encoding. So there can be a kind of let's see, a circular feeding between both things that could be exploited as well.
Yeah, there is a risen hand from Paul Taras.
Okay, if I may. So in this direction then, because I know that there's people who have been working a lot with music score and other real sources of music. Why not exploit and try to engrave that, since it's already kind of validated by, maybe not a full expert on music, but the engraving tools do impose restrictions to the kind of music that can be written.
You mean like using the library of existing music, like melodies and the content of the music?
Exactly, and since then the thing is that one of the problems of synthesis is that then if you try to use this kind of synthesized data onto end-to-end models, for instance, the problem that you usually have is that then you have co-occurrences of output labels that don't really match any kind of real musical data. So by using real data, you both sidestep restrictions in the during typesetting, things that you would not usually typeset in a real score, and you also have this added benefit of having battle tested, so to speak, melody and harmonic analysis. So that's why I was wondering if you considered that route.
Yeah, something like the deep scores dataset. Well, the deep score dataset is basically what you say, but just engraved using Veroville, I believe, or MuseScore or something like that. But the problem currently is that all of this, so we cannot really use the source data that deep scores uses. But on the other hand, I didn't really explain where the annotations for the images come from. So there are two options that we tried doing. One is generating completely random annotations. That has its pros and cons. But second, we used the premise dataset because that contains real melodies. So that gave us realistic melodies, and we could learn. The model would actually learn a language model for example, time signatures, because in the random data there would be time signature 1/9, which makes no sense. But then in the real data it was like 4/4 or 3/4, and the model knows like these are more likely, so it predicts them. So yeah, definitely like using real world melodies is beneficial.
Okay, thanks. I did miss that detail, but however, the Primus dataset, to my knowledge, I think is monophonic, right?
It is, yeah.
Okay.
That's the reason we chose it, because we limited ourselves to monophonic music.
Okay, thank you very much.
Maybe I can ask one more question that kind of tries to bridge to the third session. So, Dinesh, you mentioned that you trained on a different set of music scores of, I think it was like 8 to 10 composers. Did you evaluate your approach also on the Muskema dataset, which was obviously created for writer identification, but I guess you can also extract the kind of the underlying composers from there and then compare, because I have a feeling that if you just use the image, the raw image as the input, that you can put a lot of stress, a lot of focus on the writer and not on the underlying music. And you said you're like trying to identify the composer. Maybe you can.
Yeah, that's a nice suggestion. We can do that actually.
Okay. Well, but you haven't done it yet.
Yeah, no, we haven't done.
Okay. Okay. Maybe it would also be nice to combine that with the work from Yeji to, create more variability in the data set, synthesize it. Because the composer doesn't change if you render it differently. So that would be a really nice thing. Can you expand your approach? Like, how do you expand it if you have, if you would have more composers than your initial set?
Yeah, so actually currently we are utilizing 8 different composers. With that, we are doing different kinds of experiment, and we are restricted to just use the grayscale images right now. So with the different kind of composers, if we have more data, then we can do some experiments with the colors channels images, right? With the 3 RGB images like that, we can do some experiments with that. We can explore how it's learning different features from that.
I think what Alexander is asking is how can we get more composers in the data set? But I think what the answer would be is we'd need to retrain to include more composers.
Yeah.
Mm-hmm.
Yeah.
Okay.
I'm curious, and have you considered any metric learning approaches instead of doing typical classification? Because then not only would you be able to maybe add some extra composers, but maybe you can even compare them. From the selection of composers that I've seen, they're more or less of a relatively close period, so to speak. So maybe that would be interesting. I don't know if you have tried it and seen some result.
One thing that we did kind of discuss is how are these composers, well, we talked about how defined is their style, and that was one of the points that we had to think more of, but we haven't done any work on it yet. How close are these composers to each other? Because at the same time, the results that we're getting, they are telling us that these composers, even though of the similar periods, they're still very different to each other. But depending on the score, the classification score that we get from each one of them, some being higher and some being lower, we definitely need to think more of why are we getting such results, and how can we introduce more composers. But yeah, to go back to your point, we haven't thought on comparing these composers to each other, basically.
Yeah, thank you very much.
Okay, I think that's a great ending question, because it's already time for our lunch break. We reconvene in 1 hour and 6 minutes. So at 1:30, we'll try to catch up with the time that we spent a little more. Thank you. Again, another round of applause to all of the speakers for the first session. Thank you very much for your great presentations. And then we'll see each other again in about 1 hour for the second and third sessions. Thank you and see you later.
Thank you very much.